Hey there, imagine you're an architect and you've made this beautiful cuboid. One customer comes in and asks you that they want to make a cube with the least number of such cuboids. How many of such cuboids would you need to make more? What do you think? What could be the answer? Let's try and tackle it mathematically. Remember that to make a cube, we need groups of 3 prime factors. So let's take a number like 392. Let's try and find the prime factors. For 392, we'll likely start with 2, as it is an even number. So that's 2, and we have 2 1s, 2 9s, and 2 6. So 196, even again, so 2. 98, even again, so 2. 49, that is 7 squares. So 7, 7's 49, 7 1's 7. So for 392, we have 2 times 2 times 2 times 7 times 7. To convert this to a perfect cube, all you need to do is add another extra 7, and that will make it 3 2's and 3 7's. That makes it a perfect cube. So that would mean the cube would be 392 times 7. That is 2744, which is 14 cube, which means the side of the cube would be 14. Now let's try and apply this to our question before. To be able to find the least number of cuboids, we'll have to find the smallest cube, that is a multiple of the cuboid. Let me explain with an example. If the cuboid you made has dimensions of 15 centimeter by 10 centimeter by 5 centimeter, how many do you need to make a cube? And we also need the least number. The volume of the cuboid will be 15 centimeter times 10 centimeter times 5 centimeter, which is 750 centimeter cube. That's our cuboid. So 750 centimeter cube is not a perfect cube. To make it a perfect cube, we'll first prime factorize. And here it is slightly easier because we already have some of the factors. We can just further factorize them. So 15 is 5 times 3, 10 is 5 times 2, and 5 just remains as 5. So here we have 3 5's, 1 3, and 1 2. So 3 5's, 1 3, 1 2. So clearly we need to add 2 more 3's and 2 more 2's to match with 1 3 and 1 2. The 5's are already in groups of 3. So finally we get 750, and this is our multiple. Notice that this is the volume, which has centimeter cubes units, but this is just the multiple. That means how many of these cuboids do we need to make a perfect cube? So this volume multiplied by a number. So if you stack these cuboids in different ways, upwards, sidewards, you can make a cube. And how many of those do you need? You need about 3 3's 9, 9 2's 18, 2's 36. You need 36 such cuboids to make a cube, which is 27,000 centimeter cube of volume, which would be 90 side. The side of the cube would be 90. And that is the cube that you will be getting if you stack those cuboids. Here's an interesting bonus question for you. Starting with the number 24, what is the minimum number of operations needed to reach a perfect cube if in each step you can only multiply by 2, 3, or 5? Have a shot. See you next time.